Our new topic for today's video is series and sequences. Now, if you're in year 12 in Maths Advanced New South Wales, this is one of the topics you need to learn. So let's dive straight into it. Now, what is a series and what is a sequence? Let's say I was training for a marathon and I've never run before. So on my first day, I'm gonna run 1 kilometer. On my second day, I'm gonna run 3 kilometers. I'm feeling a little bit better, so I'm gonna start speeding up. On my third day, I'm gonna run 5 kilometers. On my fourth day, 7 kilometers. And on my fifth day, 9 kilometers. So I know this might seem a little unrealistic for anyone that actually knows anything about running, but let's just say this is what I'm doing. This collection of numbers in a list is referred to as a sequence. So this is a sequence. It is just a collection of numbers in a list. Now, the difference between that and a series is a series refers to the summation of those numbers. So if I was to sum them, 1 plus 3 plus 5 plus 7 plus 9, let's say I was trying to calculate how many kilometers I run over my first 5 days of training, that would be referred to as a series. So that's a difference. Now, we're going to get started by looking at sequences and finding terms in a sequence, and then we're going to move on to actually adding those up in a series. Now, we actually have two types of series and sequences. The first is called arithmetic and the second is called geometric. We're going to start off by looking at the first type, which, as I said, was an arithmetic sequence. Okay, so what is an arithmetic sequence? This just refers to when each term has what we call a common difference. Let me show you what I mean. If we look at the jump in kilometers between my first day of running and my second day of running, I increased by 2 kilometers. I added 2. From my second to third day, I also added 2 kilometers. This pattern continues each day where I add an additional 2 kilometers to the previous day's amount of running. This is the common difference. So the common difference, you'll see it referred to as the letter D, is just equal to T2 minus T1. Now, what is T2 and what is T1? Don't want to freak you out. This refers to term 2, this refers to term 1. So the subscript below just refers to the place of the term inside the sequence. Now, you can find this common difference by doing anything. You could, if you want to do term 5 minus term 4. You could also do, say, term 3 minus term 2. It doesn't matter which two terms you use, as long as it's one term and the term before it. If you subtract them, you will solve for your common difference. So common difference D is the second term minus the first term, which, as we can see in this sequence, is equal to 2 kilometers. Okay, we just learned what the common difference was. Now the last term left to learn about is what we call the first term, the letter A. So A always refers to the first term, which we can denote as term 1, the first term. And in this sequence, the first term is just the number 1. Now that we know what the common difference is and the first term is, we have a formula that we can learn that refers to arithmetic sequences, and it's for finding any term in that sequence. Let's say I want to figure out how many kilometers I ran on day 30. It'll take me a lot of work to sit here and adding 2 kilometers every day until I get to the 30th day. So we came up with a formula. That formula is Tn is equal to A plus n minus 1 multiplied by D. So let's break this down. The nth term of an arithmetic sequence is equal to the first term plus by the nth term that you're trying to find, so let's say 30, we'd sub in 30, take away 1, multiplied by the common difference. Let's do my example. I would like to find the kilometers that I ran on day 30. On day 30. So let's sub it in. The 30th term is going to equal my first term, A, which I know is 1, plus by n minus 1, so 30 minus 1, multiplied by my common difference, which we haven't calculated here, but as we can see it up here, it is the second term minus the first term, so 3 minus 1, which is equal to 2. So multiplied by 2. Simplifying this, it's 1 plus 29 multiplied by 2, which is just equal to 59 kilometers. That is the amount of kilometers that we ran on the 30th day of this sequence. So this is a formula that you really need to take note of. So I'm going to put a nice bubble around it. memorize this formula. For students in New South Wales, it actually is on your Mathematics Advanced formula sheet. So it isn't something that you have to memorize, but I personally feel it's easier if you memorize your formulas rather than flicking through trying to find the formula. So that's the formula, memorize that. Okay, we've learned how to find a specific term in a sequence, but what if now we want to calculate the sum of a series? Remember, a series is just a sequence that is being added together. Let's say I do 30 days of training, and we know from the previous example that on the 30th day we had run 59 kilometers. How do I now find out what is the total amount of kilometers I've run over those 30 days? So we're finding the sum. We know that the formula, the sum of n terms, is equal to the number of terms divided by 2, multiplied by 2 times by the first term, so 2a, plus n minus 1 multiplied by d. If we use this formula, we can find the sum of the number of terms that we'd like. So let's continue with my example. I'd like to find out how many kilometers I've ran over 30 days of following this pattern. So the sum of 30 terms is equal to 30 divided by 2 times by 2a. Remember, my first term is 1, so it's just 2 times by 1 is 2, plus 30 minus 1 times by, again, my common difference, which we solved before, is just the difference between term 2 and term 1. So that's 2. All right, we can now simplify this. So it's just going to be 15 times by 2 plus, we said that is 58. So 15 times by 60, which is 600 plus 300 is 900. So the sum of the first 30 days of running is equal to 900 kilometers. So over the first 30 days, let's say I was running, I've run 900 kilometers. All right, so this is another important formula that you need to learn. Again, Year 12 New South Wales students, it is on your formula sheet, but for those of you that it isn't, it's something that you definitely want to learn. That's the formula. Now, it is a little bit long, and there actually is a second formula that we can use with arithmetic sequences only when we know the last term. Now, we found the last term before earlier in this video. We found out it was 59 kilometers on day 30. I ran 59, so let's use that formula. So when I know the last term, the sum of the n terms is just going to equal n over 2, a plus l. Now, what is this l? L is the last term. So if I actually know the value for the last term, I can just sub that in. Rather than sitting there and trying to figure it all out, I can actually just sub in the last term. So the sum of 30 terms is going to equal 30 over 2. A is my first term 1 plus my last term. Earlier in this video, it's not on the whiteboard, we solved it was 59 kilometers on the 30th day. 59, that equals 15 times by 60, which again is equal to 900 kilometers. So this is another formula. It's exactly the same thing as this, but we only use it when we know what this last term L is. So if we know that last term, we can use this formula. And again, same formula is on the formula sheet, but if you don't have it, definitely something that you want to memorize. Okay, now that we've learned all the formulas for working with arithmetic series, what do we actually do with them? So let's do an example question together. We're given the series -12, -4, +4, all the way up to 84. So that's the series. It has a whole bunch of terms in between. And in question A, we're asked to find the number of terms in this series. So we don't know how many terms are sitting in here. And if we wanted, we can find the common difference and then we can start counting our way through. That would take ages. So let's use the formula Tn to find the specific term. This is normally a formula used when we're trying to find the term. But if we know the last term, we can back solve for n. Let me show you. So the nth term is equal to a plus n minus 1 multiplied by d. The term 84 is equal to the first term, which is -12 plus n. We don't know what n is. That's what we're going to back solve for. So n minus 1 times by my common difference. Now, I haven't solved for my difference really quick, but remember that the common difference is equal the common difference is equal to the second term minus the first term. So it's going to be -4 minus 12, which is just equal to 8. Remember, another way we can solve that is it's the third term minus the second term, which is equal to 4 minus 4, which again is equal to 8. So it doesn't matter how you solve for your difference as long as you get it. So my difference is just going to be 8. Okay, now expanding all of this, I get 84. Let's add 12 to both sides. So 84 plus 12 is 96 equals, and expanding this, 8n minus 8. Adding 8 to both sides, I get 8n equals 104. Dividing both sides by 8, I get n is equal to 13. So there are 13 terms in this sequence. That's the first part of this question. So moving on to question B, we know from part A that n is equal to 13. We now ask to find the sum of the series. Remember, we have these two formulas. We can use either formula for this question. So we can use this one. It's a little bit longer though. We should use this one because we know what the last term is. The last term of this series is 84, so it's probably easier to just use this one. So the sum of the first 13 terms is equal to 13 over 2. Remember that 13 comes from question A. So 13 over 2 times by A, which is my first term, minus 12, plus my last term, which is 84. Okay, simplifying over this, all of this, it's 13 over 2 times by minus 12 plus 84 is going to give me 72. Putting that into the calculator, we just get 468. That is the sum of all of the terms in this series, and that's how you start using these formulas in questions. Now that we've learned all the formulas and done some practice questions, let's finish off with a Year 12 HSC Trials question. This was worth 3 marks in a trial paper. We're asked to find the sum of the following arithmetic series. So 9 plus 16 plus 23, all the way up to 2,963. In order to find the sum of this series, we're going to use the formula. The sum is equal to n over 2a plus l, where a is the first term and l is the last term. So we know the first term, we know the last term, but we don't know how many terms are actually sitting in this series. There's a whole bunch of terms in between. So we're going to use the first formula here, and we're going to back solve to find n. So Tn, let's let Tn equals a plus n minus 1 multiplied by d. That's the formula. Let's look at the last term. So 2,963 is equal to a, the first term, plus by n minus 1. N is what we're solving for, and d is the common difference. So the difference between 16 and 9 is 7. Expanding all of this, we get 7n is equal to 2961. Dividing both sides by 7, we get n is equal to 423. So there's 423 terms in this series. All we can do now is we come back to this formula up here and we sub it in. So our sum is going to equal 423 divided by 2, multiplied by a, the first term, which is 9, plus the last term, 2963. Now, all you need to do is put this into your calculator, simplify it, and you get 628,578. That is the sum of the first 423 terms. We know there's 423 terms in this series. So that's it for arithmetic series and sequences. Check out part 2 of this series where we're going to be looking at geometric series and sequences. Let me know in the comments section if you guys have any questions about how any of this works. And let me know what videos you want to see next. This is part 1. Check out our YouTube channel. Let me know what else you guys want to see. Excited to make some more videos for you. Catch you in the next one.